Hi everyone, I hope everyone is doing well. Today's tutorial is about a topic in JavaScript that many developers find a bit intimidating: closures. In my nearly 17 years of programming experience, I have noticed that just hearing the word closure makes a lot of JavaScript developers nervous, almost instinctively. So the main goal of this tutorial is to remove that fear. By the end of this video, you should be able to confidently say, no more fear of closures. Closures aren't actually complicated at all. We often make them seem hard just because we don't understand them clearly. Many tutorials don't explain the topic deeply, which leaves us confused, asking questions like what exactly is closure? Or what does it really mean? In this video, I will walk you through several examples step by step, so it might be a bit long. But if you stick with me until the end, I promise all your confusion about closures will disappear. Let's get started. Usually, when we want to use an outside variable inside a function, we pass it as a parameter. For example, let's say we write a function called sum. Here, two numbers are taken as parameters. Now, if we want to add these numbers and return the result, we write return num1 plus num2. If we want to see the output, we write console log and pass sum2 3. The output will be 5. Simple, right? But in JavaScript, there's a way to do the same thing without passing parameters. How? Now let's remove the parameters from the sum function. Then, outside the function, in the global scope, we define two variables, num1 and num2. Now, even if we call sum function, the output will still be 5. So the question is, how does JavaScript do this? It seems a bit strange, right? Inside a function, we are using variables that don't actually belong to that function. They exist outside the wider environment where the function was created. In simple terms, the function is using variables from its parent scope. We did a video on scope before. This is actually one of the most fundamental concepts in JavaScript. Everything from a parent is accessible to the child. And if there were nested functions inside this function, even the deepest child function could access variables like num1 and num2 from the parent. In other words, the parent's variables are fully accessible to the child, but nothing from the child can be accessed by the parent. For example, if we define a new variable inside the sum function, it cannot be accessed from outside the function. We covered this in detail in our previous scope video. If anyone wants a quick refresher on scope, the link is in the video description. So, this is the core idea of scope. We said that the system of scope is theoretically called lexical scoping. Now, you might wonder, since today's topic is closure, why are we discussing scope so much? It's because closures and scope are deeply connected. Understanding scope is essential before we can truly grasp closures. Now, according to lexical scoping, a child function can access its parent's variables, but a parent cannot access the child's. This isn't random. It's a specific convention or guideline in JavaScript. But how does this actually work under the hood? Imagine we are solving a problem. That's when closures come into play. Understanding closures is crucial for situations like this. The word closure literally means a bond or enclosure. Think of it like keeping a variable safely locked away, just like storing something inside a box. Even though the box is closed, we can still use its contents when needed. This is why it's called a closure, because we keep a function's variables enclosed in such a way that even if the outside world cannot access them directly, the function itself can still use them whenever required. To understand closures properly, we need to remember one more small point. In JavaScript, whenever we write a function, the function is actually treated as an object. Yes, every function in JavaScript works as an object. Just as we can console log an object to see it, we can also console log a function to inspect it. Now, let's print our sum function. For that, we write console.dir and pass the sum function body. Notice that we are not calling the function, we are just printing its body. We use dir instead of log, because console log only shows the function body, while console.dir displays the function as an object, letting us see each of its properties one by one. You can think of it as an upgraded version of console log. Looking at the output, we will see an object. Expanding it reveals many properties like name, length, prototype, and more. At the very bottom, there's a property called scopes. Inside scopes, there's a section named global, containing even more details. Today, we will mainly focus on this scopes property. Now notice something. The sum function has its own world, right? So why is it still referencing the global scope? Every function actually maintains a connection with its parent environment. It doesn't just live in its own world. It keeps a link to the environment where it was created. Simply put, it always holds a reference to its parent. Why does it do this? Because if anything changes in the parent environment, like a variable's value or the need to use it inside the function can still access it. This whole process is the core concept of a closure. A function keeps track of the variables it uses from outside its own scope by closing over its parent and its parent's parent, essentially the entire scope chain above it, holding them as references. That's why we said this example is actually the simplest form of a closure. The sum function itself is a closure because it has captured some variables from its outer environment and can use them whenever needed. Even though we often see closures explained with examples where a function is inside another function, the fundamental idea starts here. Any function that retains access to variables from its outer scope is, in essence, a closure. We can understand this even more clearly if we tweak the previous sum function a bit. In the earlier example, we directly wrote return num1 plus num2, right? This time, instead of doing that, we will have the sum function return another function, return function. And inside this inner function, we write return num1 plus num2. So, what does this mean? The sum function is no longer returning a value directly. Instead, it's returning a function. Now, let's create another variable called myFunction. Var myfunc is equal to sum. What happens here? We call the sum function, and whatever it returned, the inner function is now stored in myFunction. In other words, myfunc is essentially the inner function returned by sum. Makes sense, right? If we now print myfunc to the console.dir myfunc, we will see num1 and num2 listed as variables in the output. What does this mean? This function is still holding on to its global environment. Even though it's an inner function, it's still connected to the global scope and maintains the same global references as before. Now, let's do one thing. Remove the num2 variable from the global scope and define it inside the sum function instead. Now let's look at the output again. This time in the browser, we can clearly see something labeled closure. In other words, the browser is directly showing that a closure has been created inside this function. In older versions of Chrome, even in the previous example, you would have seen closure here. But in the newer versions, it shows as global until a function actually closes over another function. So, whenever a function is returned from within another function, that's when the browser displays closure. However, keep in mind that theoretically, the previous example was also a kind of closure. The difference is just in how the browser presents it. When we did console.dir myfunc, we saw that this inner function is using both num1 and num2. Where is num1? In the global scope, and num2 inside the sum function scope. So, what is this inner function doing? It's taking a reference to num1 from the global scope and at the same time taking a reference to num2 from its parent function, sum. In other words, this inner function now carries two worlds within it. One is the global scope and the other is its parent scope. This is exactly what a closure does. It keeps all the outer scopes it needs enclosed so it can use their variables whenever necessary. In the browser, we can see that inside this closure, num2 exists, while num1 remains in the global scope. So, num1 is no longer part of the closure. What does this mean? The function only carries the parts of the environment it actually needs for its execution. Simply put, it takes all the variables it needs along with their references as a compact package. Think of it like the function holding on to references. Whenever any of these variables are updated, the function can see those changes because it's still connected to the same references. So let's say we called myFunc is equal to sum once. Now, if we keep calling sum function repeatedly, there's no problem. Each time a new function will create its own separate scope and keep a reference to that scope. In simple terms, we defined a function and then called it elsewhere. Every time we call that function, it can still access the data from its previous scope. That's because every function preserves all the information from its parent scope as references. This is exactly how a function remembers its outer variables. This is what a closure is. So, as far as we understand, this is the core idea of a closure. Hopefully, it's clear to everyone now. Now, we move to the next step. This will be a bit more advanced. I will explain very slowly, so it might take that video a little longer. Closures are really important, and my goal is that after watching this video, no one will be afraid of the word closure. Those who watch from start to finish should have a complete understanding of closures. There's nothing to fear about closures. They are actually very simple. Imagine a function. If it wants to use a variable or data that exists outside its own world, it brings the parent scope of those variables along with it. In other words, it closes over the entire parent scope where those variables exist. This is the concept of a closure. Hopefully, it's crystal clear now. Next, we will look at several examples one by one to understand the concept more deeply. We will also go through different use cases so it becomes easier to grasp. So, let's get started. Think about other programming languages. When we want to create a private property, what do we usually do? In other programming languages, we define a property inside a class and mark it as private so that no one can access it directly from outside the class. Then, inside the class, we create one or more public functions like getters or setters, which allow controlled access to or modification of that property. In other words, you can't touch the property directly from outside. You can only interact with it through specific functions defined inside the class. In JavaScript, we can achieve the same idea much more simply using closures, entirely in a functional style. How? Let's see an example. Suppose we have a simple function bank account and pass initial balance. We have named it bank account and it takes the user's initial balance as a parameter. Inside it, we define a variable var balance is equal to initial balance. So the user's initial balance is stored internally in a variable called balance. Next, we return a function that returns this balance variable. In other words, the balance can only be accessed through this return function. Outside, in the global scope, we create a variable var account is equal to bank account and pass 150 zeros. Here, we call the bank account function and passed 150 as the initial balance. What is this function actually doing? It's returning another function. So now the account variable holds that return function. If we write in the console.log and pass the account function call, the output will be 150. But if we try console.log and pass balance, it won't work because the balance variable cannot be accessed from outside. What does this mean? The balance property is protected or private. No one from the outside can directly touch it. To see the balance, you can only call the return function inside the original function. This is how we keep balance as a private variable and control access to it. So, what's the role of the closure here? It's exactly what makes this possible. The inner function is the closure. If we write console.dir and pass account, we'll see that inside the account function is the return function. Expanding it, we'll see that the balance variable exists inside the closure. Exactly right. This means that balance wasn't created inside the account function itself. It was created one scope level up. Yet, we can still access balance from the return function. It's similar to the previous example, but this use case is slightly different. Here, we are showing how a private property can be kept secure. Even though we called the inner function from the outside, it still had access to balance within its scope. So the outer scope cannot directly access balance, but thanks to the closure, we can maintain a reference to it. Even though the function is called from outside, the closure allows us to access the private property in a protected way. Why protected? Because we are not accessing it directly. We can only see balance through the function call. This is another powerful use case of closures. Securing private properties so that they cannot be directly accessed from outside, but only through specific functions. So this is one of the powerful features of closures. Now let's look at another aspect of closures. Let's revisit our first example. In that example, we used a variable called num2 inside the inner function. That's why the function acted as a closure. Now, let's keep the variable but stop using num2 inside the inner function. If we check the output, we will see that the closure is gone. Do you see why? It's because num2 isn't used inside the inner function. JavaScript smartly recognizes that this variable isn't needed, so it's not included in the closure. In other words, JavaScript decides on its own. Variables that won't be used inside the function, even if they exist in the outer scope, aren't included in the closure. Only the variables that the function actually needs become part of the closure. For example, if we define another variable inside the sum function, var num is equal to 6, and do nothing else, there's still no need for a closure. But if we modify the inner function to return num instead of num1, what happens? You'll see the closure appears again. This time the closure contains only num. Num2 won't be there, but num1 remains because it exists in the global scope. JavaScript preserves this scope to maintain lexical scoping. For instance, if we look at the global scope, we can still see num1, right? That's because we used the var keyword. If we had used let, it wouldn't be visible. We will discuss this issue later to avoid confusion. The key difference we are noticing is num1 exists in the global scope, so it remains in the closures environment, but if a variable inside the inner function isn't used, it's not included in the closure. For example, here, if we use num1, we are accessing the global variable. So what happens now? Will there be a closure? Look, there isn't one. Since num1 exists in the global scope, there's no extra need. The global scope is sufficient and no separate closure is required. This shows how closures actually work. A closure decides which variables need to be kept inside the function and which don't. JavaScript makes this decision automatically. We just need to remember lexical scoping so that outer scope variables can be accessed. In simple terms, closures make intelligent decisions. Variables used inside the function are kept inside. Variables in outer scopes that aren't used aren't included. And global variables are accessible directly. So there's no need to include them in the closure. So here we kept num1 and it exists in the global scope. The function can access it directly from there. But if the inner function used only num, which doesn't exist in its own scope or globally, then a closure would have to be created to carry that variable along. In short, a closure doesn't wrap everything. It doesn't include variables that are already outside. This is an important point. Another important point is that global scope variables are never included in closures. Now, let's move on. Often, there's confusion about what a closure appears and when it just shows global. Even senior interviewers sometimes hesitate to call the global scope a closure at first glance. So, what's the real point here? Let's break it down. If we look at JavaScript documentation, Mozilla maintains it. I visited their site and checked the 2016 documentation before the current definition. According to that old documentation, the definition of a closure back in 2016 highlighted something important. In the brackets, it said variables that are used locally but defined in an enclosing scope. This means variables that are used locally inside a function but are actually defined in an outer scope. This is the key point. In our previous examples, this is exactly what was happening. Only variables that are actually used inside a function are included in the closure. Variables that exist in an outer scope but aren't used inside the function aren't part of the closure. In simple terms, a closure is a function that remembers its local scope along with the necessary variables from an outer scope. So even if the function is called from outside, it can still access those variables. Now let's go back to our example. Suppose we have a variable num defined outside, but we use it locally inside the function. That's why the browser shows it as a closure, just like the documentation says. But if we don't use the outer variable inside the return function, like before when we did return num1 plus num2 directly, what happens? We removed everything else and just return num1 plus num2. If we call the sum function directly, it works fine. But if we did console.dir sum, what do we see? The word closure doesn't appear. Why? Because num2 is local inside the function and there's no need to include it in a closure. A closure is only needed to use variables from an outer scope. Since this is the very first level outer scope, meaning the global scope, and it's not inside any function, the sum function is already capturing it in its own scope. So no additional closure is created. Now the question is, when does the browser show a closure and when doesn't it? That's the critical point. The explanation comes straight from the documentation. Variables that are used locally but defined in an enclosing scope. Look, our num1 variable is defined outside but used locally inside. However, num1 doesn't have any enclosing scope. Here, an enclosing scope means a scope that wraps around another scope. For example, inside a set of brackets. But num1 is directly in the global scope, not inside any enclosing scope. If we want to bring this into an enclosing scope, we need to wrap the whole thing inside a function. We can write an anonymous function like this. Then we put everything inside that function and immediately call it. This is known as an immediately invoked function expression, or IIFE for short. Basically, it's a function that gets defined and executed at the same time. When we use an IIFE, everything gets moved into an enclosing scope. The num1 that was previously open in the global scope is now inside this function. So it's now part of an enclosing scope. If we check in the browser and expand it, everything looks the same as before, but now we see the word closure, right? That's because we have brought the variables into an enclosing scope. So the browser now shows it as a closure. To clarify, if someone ever gets confused or disagrees, they might say the outer one isn't a closure. It's just a global scope. But theoretically, we can still consider it a closure. Some might insist that's a closure, while others may not agree. For those who don't, this explanation helps. The thing is, JavaScript always keeps the global scope intact to maintain lexical scoping. People who disagree with me might say the global scope is just preserved. That's not a closure. And that's fair. But the concept is really the same. If a variable from an outer scope is used or referenced inside the function, it behaves just like a closure. The idea is consistent. There's a small difference though. The global scope keeps all variables that exist outside any function. That's why some might argue it's not technically a closure. But from a theoretical perspective, it behaves like one, with only minor differences for global variables. If we hadn't done this and went back to the previous setup, the browser would no longer show it as a closure. Look, now the browser doesn't show it. And the var num1 is in the global scope, right? So num1 is being used here. Now, if we add another variable below it, like var num3 is equal to 5, this num3 isn't used by the sum function. But if we look in the global scope, we can still see it. The browser shows num3 as well. But as we saw earlier, a closure only keeps what's necessary. Here, num3 exists because it's part of the global scope. The global object always holds references to its own variables, which is why num3 is visible. This often causes confusion. Should we call it a closure or not? My point is, in the 2016 documentation, the term enclosing scope was clearly mentioned. In the current documentation, that phrase is missing. This means they have intentionally avoided that confusion. The modern definition now says closure is the combination of a function bundled together, which is written in a more complex way compared to before. In the updated definition, it says closure is the combination of a function bundled together with references to its surrounding state. Here, state refers to the lexical environment. That could be the child's environment, the parent's environment, or the entire scope. Based on this definition, it means a function keeps itself along with any variables it needs to remember all bundled together. Explaining this clearly in words can be tricky, and I might not fully capture it right now. But we will see some examples ahead, which will make each use case clear. We will show that mistakes can happen, why we use closures, why understanding them is important, and why closures are asked about repeatedly in interviews. While following this tutorial and seeing more examples, everything should become much clearer. Now, let's look at another aspect. We are going back to the previous IIFE function. Here, we have a function called sum that adds num1 and num2 and returns the result. Both num1 and num2 exist inside the IIFE function. This means we have kept the whole setup self-contained within a closure function. Now, when we call the sum function, console.log and pass the sum call, and on the next line write console.dir sum, let's check the output. Initially, 2 plus 3 gives 5, which is exactly what we see. Since num1 and num2 now exist inside the global scope of the IIFE, we can modify these variables if we want. Num1 is equal to 6, num2 is equal to 7. Then, if we call again console.log sum and console.dir sum, we'll see two different results. The first call returns 5 because initially 2 plus 3 was calculated. After changing num1 and num2, the next call returns 13. So, we can see that a closure keeps hold of the outer variables and makes them accessible inside the function. Now, at that moment, we check the function using console.dir. Remember? First, we expand the dir at the bottom. Here, we see an entry labeled as closure, and inside it, we notice num1 is equal to 6 and num2 is equal to 7. Great, because before writing dir, we had changed the values of num1 and num2. So, it's showing the latest values. But if we go back to the previous state and expand the first console.dir, surprisingly, it still shows num1 is equal to 6 and num2 is equal to 7. Both are the same. Pretty weird, isn't it? That's because when we did console.log, the result showed 2 plus 3, but in the very next line, the values hadn't actually changed yet. In the console.dir, you see that inside the closure, the values remain 6 and 7. This is exactly what we have been emphasizing. A closure doesn't really hold the values themselves. It holds a reference to the variables. So, what does this mean? It means that there's a pointer stored to the memory location of our variable. Once a reference is stored, the pointer itself stays the same, but the value can change anytime. When we use console.dir, the browser is showing that reference, which is why it always displays the latest values. The browser works very fast and the reference has already been updated. When we set num1 and num2 to 6 and 7 inside the closure, the reference gets updated. We are seeing the exact same variable, but we don't see the intermediate values. However, when we do console.log, the function uses its corresponding values correctly. That's why not every change in the intermediate scope is clearly visible. Because of reference updates, we always see the latest value, not the direct intermediate state. So, here's an important point to understand. A closure doesn't store the actual values inside. It stores references to those values. Keeping this concept in mind is really crucial. Now, let's look at another aspect of closures. Let's go back to the previous example. Earlier, we declared two variables in the global scope, num1 and num2. So far, we have been using the var keyword. So the output will reflect that accordingly. Now, if we don't put anything inside an IIFE and just stay in the global scope, we won't see any closure in the browser. But where do num1 and num2 live? Obviously, in the global scope. That's why we write console.dir sum. In the browser, we can see num1 and num2 inside the global object. Now, here's the interesting part. What happens if we replace these var keywords with let? Let's check that out. This is where the difference between var and let comes in. Many people think they are the same, but in JavaScript, var and let are not equal. Simply put, var is the old JavaScript declaration and its function scoped. That means a variable declared with var only lives inside the function it's defined in. If it's defined outside any function, it goes to the global scope. On the other hand, let is the new ES6 declaration and it's block scoped. That means a variable declared with let only exists within the block or scope where it was defined and cannot be accessed from outside. One important difference is hoisting. Variables declared with var are hoisted, meaning JavaScript moves the declaration to the top, but the initialization doesn't happen. So if you use a var before it's declared, you will get undefined. With let, even though it's hoisted, the temporal dead zone ensures that using it before declaration throws an error. So let's see what happens if we declare the variable with let. I have already provided a detailed tutorial on hoisting in this channel, so please check that out for more information. The link to that video is in the description. So let's see what happens if we declare the variable with let. Last time, when it was just in the global scope, we could see the variables when we did console.dir. Now, whenever we see a new object named script has appeared and num1 and num2 are no longer in the global scope. Why is that? It's because of the difference between let and var that we talked about earlier. Let is the block scoped while var is function scoped. If we treat the outer context as a main function, a variable declared with var becomes part of the global scope. But with let, it stays within its block scope and doesn't directly become part of the global object. So let actually lives inside a separate object called script and not in the global scope. Understanding this is really important because if you follow the tutorial and try printing variables while using let out of habit, the output won't be like it is with var. This can definitely be confusing. Simply put, let doesn't go into the global object. It exists inside a separate script object. But what if we wrap the whole thing in an enclosing function again? Like before with an IIFE, where a self-invoking function calls itself. Let's copy this code and paste it inside an IIFE. When we check the output now, everything goes back inside its closure. Ultimately, the concept of closures remain the same. What changes is whether the variable goes into var or let scope. Now, the situation becomes a bit simpler. We have a function and it's in its end closing state. According to the definition of a closure, the inner function of this function is using the outer variable name1. So this inner function definitely needs a closure. That closure comes from exactly this function. JavaScript creates the closure and packages name1 inside it. The outer global world always exists separately, of course. Also remember, when using console.dir in the browser, the output will look different depending on whether you are dealing with let or var. So far, all the examples we have seen were very simple. Now, let's look at a practical example that will help you understand closures better and clear up any confusion. Let's define a function. Function Stopwatch. We have named it Stopwatch and it will work just like a real stopwatch. Like when we start a stopwatch, wait for a while and then stop it to get the elapsed time, this function will do the same. First, we write var start time is equal to date.now. This stores the current time in start time. Then inside the function we define getDelay is equal to function. We create a getDelay function which will log the elapsed time to the console. For that we write console.log date.now minus start time. Here the elapsed time is calculated by subtracting start time from the current time. Finally, we simply return this getDelay function. The stopwatch function does just one thing. When we call stopwatch, it starts a stopwatch using date.now and returns a getDelay function. When we call that getDelay function, it shows the elapsed time from the start time to the current moment. So that's the entire purpose of the function. Now let's call it. We write var timer is equal to stopwatch. Here we have started the stopwatch. This function executes, which means start time is set and the getDelay function is defined. The stopwatch function itself isn't called directly afterward. We simply called it once and the outer function returns the getDelay function. We stored this return function in timer. Now, on the next line, we will create a fake delay. At this point, the stopwatch is already running because we called it, but we haven't printed anything from getDelay yet. Before calling getDelay, we create a fake delay like this. For let I is equal to 0, I less than 10 crore, I++. Here, we use a large for loop to waste some time. We chose a big number intentionally so it takes a noticeable delay. If we want, we can also perform some expensive operations in the loop, like calculating a random number. Math.random into a huge number. This way, we create a fake delay. Now, let's come to timer. Timer is actually a function because it was returned by calling Stopwatch. This return getDelay function acts as our actual timer. Now, let's call timer and see what happens. The output doesn't appear instantly. It takes a moment and then it shows up. So, we get a delay. The question is, how is this still working? The stopwatch function where we initially called it has already finished executing. That means everything inside that function should be gone. So, how does timer still know the value of start time? Especially after we added such a long delay before calling it. This means the timer function still remembers its parent function, especially the start time variable inside stopwatch. It holds on to that reference. How? Because of a closure. When getDelay was created, a closure was also created inside it that kept track of the start time variable. So, even after the delay and even after a long time, it can still use that old value. This shows that JavaScript is really smart. It tracks all variables, references, and closures, and when needed, it can use them again. Here, we are just demonstrating how closures work. The rest is handled automatically by JavaScript. It knows when something is needed and makes sure it works. This is why this behavior is possible, because of closures. If we do console.dir timer like before and check the output in the browser, you will notice it takes some time to appear because of the delay. But even after the delay, it still remains start time inside the closure. If we try console.log start time, we won't be able to access start time directly. But since timer is a member function, it can use that start time we initialized long ago, before the for loop. It still remembers start time. No matter how long the delay, it can keep track. Even if there were more lines of code or more expensive operations during the delay, at the end of the day, when we call the timer, the closure ensures that start time is correctly preserved. This is one of the fascinating aspects of JavaScript. It can really remember such information, and this is one of the biggest use cases of closures. Because of closures, no matter how many times we call the timer function, each call works independently and keeps its own start time reference. Every time, a new reference is created and held as long as it's needed. This is a small example, but in a large application, there could be countless closures holding references to many variables. Naturally, the question arises, if so many things are being remembered, will performance suffer? This is where JavaScript's performance optimization comes in. JavaScript is a smart, garbage-collected language. That means when JavaScript realizes that a reference or variable is no longer needed, it automatically removes it from memory. In some situations, programmers can manually optimize. For example, in our case, we created a timer holding a reference to the getDelay function, but we haven't called getDelay yet. JavaScript doesn't know if it will be used in the future, so it keeps the reference. If we are certain it won't be used anymore, we can manually clear the reference by writing timer is equal to null. Now, timer won't work because we set it to null. JavaScript understands that it's no longer needed and garbage collects the reference from memory. If you try this in the browser, you will see an error, type error, timer is not a function, because timer is now null. Simply put, setting timer is equal to null tells JavaScript this variable won't be used anymore. Forget it. The garbage collector then recognizes there are no references and quietly removes it from memory, preventing memory wastage. The interesting part is that JavaScript doesn't just run the code. It predicts a lot even before compilation. When it sees timer is equal to null, it already knows, okay, the programmer used this timer only this much and it won't be needed anymore. So, as soon as the code finishes running, it intelligently cleans up the memory. This makes our program automatically optimized. There are no memory leaks or browser load decreases, and JavaScript executes faster. This is a very small example, but it already shows how elegantly you can manage performance in JavaScript. So far, all the examples we have seen were using closures in a synchronous way. Now, many people might wonder, okay, but how do closures work in asynchronous situations? That's a very good question. In real-world coding, most tasks run asynchronously, like with setTimeout, fetch, or event listener functions. The key point is, synchronous code executes line by line, but asynchronous code takes some time to complete. That means you call a function, but its result arrives a little later. So the question is, if the outer scope has already finished by then, how does the inner function still remember the values of the outer variables? This is exactly where the true power of closures come in. A closure keeps the references to the outer scope as long as the inner function hasn't executed yet. That means whether the code is synchronous or asynchronous, closures work the same way. Now, let's see a small asynchronous example to understand how closures work and why they are just as reliable in asynchronous scenarios. We define a function async example. Inside this function, we write var a is equal to 20. We have defined a variable. Next, we will use JavaScript's built-in setTimeout function. For that, we write setTimeout and pass a function. We all know that setTimeout takes two parameters. One is the function to run and the other is the time in milliseconds, meaning it will call that function after the specified delay. Now, suppose we put console.log a inside that function. Surprisingly, even though a isn't defined inside the timeout function, it can still access the a from async example's outer scope. This is possible because of closures. We did exactly the same and then finally called the async example function. Now, let's check the output. After 3 seconds, it appears and we see 20. This is also possible because of closures. The function inside setTimeout doesn't have a defined within itself, yet it can access a from async example scope. Now, what if we define the setTimeout function outside async example just for demonstration, like this. Function myfunc. Inside myfunc, we write console.log a. Then we pass myfunc into setTimeout and also write console.dir myfunc. If we check the output of console.dir, we will see that inside myfunc, the closure contains the variable a is equal to 20. This is because a was part of async example's scope, so myfunc can still access it. Just like before, this is possible thanks to closures. But here, there's a subtle difference. Earlier, we talked about a reference example, but this reference works a little differently. Suppose the variable a is equal to 20 was originally inside async example. Now, if we move a to the global scope and write var a is equal to 20, in simple terms, we have defined it outside. Now, the closure won't show it because it's part of the global scope. A will just exist in the global scope with a value of 20. We call the async example function, which starts the setTimeout timer. Then on the next line, after calling async example, we change the value of a. A is equal to 30. Now think, if myfunc is called as the callback for setTimeout and does console.log a, what value will it show? If you check the output, it will show 30. What does this mean? When async example is called, the setTimeout starts and myfunc is ready as the callback. Inside myfunc, we have console.log a. At that moment, a was 20 in its parent scope. But since a is now global and its value has been changed from outside, when the callback executes, it shows 30. This demonstrates that closures actually hold a reference to the variable. If the variable is global, any external changes are also tracked. So, if we expand the global a in the console, we'll see a is equal to 30. I mentioned earlier that closures keep a reference to the value. So, when setTimeout sends the callback to the main thread after 3 seconds, myfunc can still access that reference. Remember, myfunc comes back via setTimeout from another place. It doesn't run directly on the main thread. This is part of asynchronous JavaScript. The function is called in the main thread after returning from the web API, but it still retains the reference to a. Since a has been changed globally, when myfunc prints it, it shows the new value 30. This point is very important. Practicing multiple examples will help you better understand how closures track outer variables in asynchronous situations. This is why you need to be careful when using global variables and var. This is also the reason var can sometimes cause conflicts and why the let keyword was introduced. For example, if we define var a globally and later change a somewhere in the program, any asynchronous functions referencing a will use the new value. That's why using var with setTimeout or other asynchronous functions can lead to such issues. An important point is that a closure doesn't keep the entire variable from its parent scope. It only keeps a reference to that variable. Now, let's see another practical example of closures. In typical JavaScript applications, we often make AJAX requests to fetch data from an API URL. We'll see how closures are used in this context. We know that for API requests like this, JavaScript's built-in fetch function can be used. Though third-party libraries like Axios or jQuery AJAX can also accomplish this same task. We will use fetch for a practical example. First, we write a function, API function, and pass the URL. We named it API function and gave it a parameter called URL. This function will send a request to that URL. So, what does fetch do with the URL? Basically, fetch returns a promise. We know that to get the output from a promise, we use then. So, we write .then res and return something. After the response comes back, we use a callback function. Here, we log the response to the console.log, and pass the res variable. This is how our API function is set up. Now, we will call the function. We need to pass a URL for the API call. A popular choice is JSON placeholder. So, we use it /todo/1 endpoint. We write API function and pass the full URL. Let's check the output. Notice that it appears after a short delay. This is asynchronous. To make this clearer, we write another line below. Console.log, I am here. Now the question is, which prints first? Without a doubt, I am here prints first, and then the output from API function appears. This clearly demonstrates the flow of asynchronous operations. Since the response comes quickly, it might not have been obvious without this extra line. What does this mean? The output is coming, right? Here, the connection to closures is that we pass the URL parameter from outside when calling API function. This URL now exists inside the body of API function. Fetch takes it as a parameter, and then the callback function inside then executes much later. By that time, the call to API function has already finished, but the callback still remembers the variables from its scope. That's why even after the result arrives, we can still access URL. To see this, we can print it. Console.log URL. Notice that the output is correct. This means that if there were more nested functions inside then, like another then inside a then, all the way down, the innermost function could still access the original URL. And this is possible only because of closures. To demonstrate, we can rewrite the callback function inside API function a little differently. Function handle response. This function simply does console.log URL. Now we pass handle response into then. Then we write console.dir handle response. In the output, we'll see that inside handle response, the closure contains URL. This is because it was part of API function's scope, so it can access it. Hopefully, this makes it clear. Finally, let's look at another example that often comes up in job interviews. This one is a bit more complex and tricky, and it shows how using closures inside loops can create unpredictable output. Suppose we write a simple for loop. For let I is equal to 0, I less than 3, I plus plus. This loop will run 3 times, and inside it we define another function A. Inside this function, we simply do console.log I. From this, we see that the function A exists within the scope of the for loop, but in reality, it's also accessible in the global scope. Then we call the function A. The expected output would be 0, 1, 2. First, the value of I prints 0, then 1, then 2, one after another. Now, looking at the output, we see 0, 1, 2. This is because we defined I using let. If we remove let and use var instead, what happens? Even with var, the output will be the same in this simple case because var works outside the block scope. That is, writing for var is equal to 0 or declaring var I separately behaves effectively the same. So in this case, there's no problem. A closure isn't required because we are running the function in the global scope. Our I prints 0, then 1, then 2. Everything works correctly. Now let's go back and use let for I again. Suppose we want to call the a function from outside the loop. Imagine we wrap the whole thing in a setTimeout, and in the first parameter we pass the body of a as a callback, while the second parameter is 1000 into I milliseconds. Using this 1000 into I, we want 0 to print after 1 second, 1 after 2 seconds, and 2 after 3 seconds. When we run this, the output comes exactly as expected. After 1 second, 0 prints. After 2 seconds, 1 prints. And after 3 seconds, 2 prints. But here's the important point. The for loop itself is synchronous, while the functions inside setTimeout are asynchronous. That means the functions inside setTimeout will execute one by one according to the timer, only after the loop has finished. First after 1 second, then after 2, and then after 3. We can verify this asynchronous behavior. Suppose at the end of the loop, we write console.log after for loop. Now, if we check the output, after for loop prints first. Then after 1 second, 0 prints. After 2 seconds, 1 prints. And finally, 2 prints. This clearly shows how asynchronous functions execute, right? No confusion there. The interesting part is, if we use var I instead of let I, the behavior changes. All 3 outputs end up being 3. We don't get 0, 1, 2 like before. That's exactly the tricky part of this question. This question often comes up in job interviews because it's a bit advanced. But if you understand closures and the difference between let and var scopes, it's not complicated at all. Let's analyze this by going back to the let. So remove var I and write let I is equal to 0. Now the expected output is 0, 1, 2. Let is blocked scope, meaning this I exists only inside the loop and has no effect outside. During the first iteration, I is 0 and the setTimeout function is defined. This function will be called after the loop finishes. So a closure is used to remember the value of I. The callback needs a closure to reference I correctly. Since let doesn't leak outside the loop, each iteration creates a new I. For example, when I becomes 1, it's a completely separate I from the previous iteration. So when this function runs the second time, it references this new I. But with var, the situation is different. Var is function scoped, so the same variable exists outside the loop. If we write var I and then use the loop, there is only one I. Changing I inside the loop modifies the same I. No new I is created. So when the setTimeout callbacks execute, they all reference that same I. From previous examples, we know setTimeout callbacks run after the loop finishes. Now, after the loop ends, what's the value of I? Since we used var, I has become 3. Check it with console.log I. In the console, you will see 3 prints first. That means when the callbacks execute, they all reference the same I, which is already 3. So every console.log in the callbacks print I is equal to 3, which explains the output perfectly. To understand this even better, we can use console.dir like before. Let's see how. First, we will stick with the let case. So in the for loop, we write let I is equal to 0. We comment out the global var I since let is blocked scope. Now let's see how the closure works. The closure is created inside the setTimeout callback function, and we want to inspect this callback function. For that, we define function myfunc and pass this myfunc inside setTimeout. Then to inspect it, we write console.dir myfunc. If we run this, the browser shows the same output. That means the dir of my function appears 3 times, but in Chrome's console, it only prints once. Chrome wraps similar objects together. So even though the internal properties are different, it doesn't display them separately. To see each property individually, we take the next step. Below the dir, we write console.log --. This acts as a separator. Now, when the browser prints myfunc's dir, it also prints the separator, making it clear that each instance is separate. At the same time, outside the for loop, we add console.log after for loop. Now, if we check the output, the browser prints after for loop first, then 0, 1, 2. In my execution, when we defined it, the console logs show my func and the dashes. Notice when I is 0, the closure holds I is equal to 0. When I is equal to 1, the closure holds I is equal to 1. When I is equal to 2, the closure holds I is equal to 2. So, all three values exist as references until the end, which is why we get three separate outputs. But what happens if we replace let I with var I? After printing after for loop, all three outputs show 3. How? When I is 0, there's no closure because var moves this variable to the global scope. Unlike the previous example, no closure is needed here. Var exists in the global scope and I changes within that same global variable. So, if we expand the first myfunc in the console and look for I in the global scope, you will see I is equal to 3. Why? Because the for loop finishes first and at the end, I becomes 3. At the moment of after for loop, I is 3. This means when the reference values are called, they still use the reference to that I. Even if I changes later in the program, since the calls happen afterward, the reference values get the updated I. That's why the first call shows 3, the second call shows 3, and the third call also shows 3. If you expand them all, you will see I is equal to 3 everywhere. This happens because no closure is used here. It's referencing the original I in the global scope, which keeps updating. The difference in scope between let and var is why the output changes completely. Hopefully, this is clear now. To fix this var issue, now we can create an IIFE inside the for loop. This IIFE will take one parameter. In this case, the value of our loop variable I. Alright, let's write the code. Inside the IIFE, we are passing a parameter named I. Of course, you can name it anything you want. You already know that. But for now, we will just keep it as I. Then we call the IIFE. We will pass the loop's I value into it. Nice, right? Let's see what the output looks like. This time we get 0, 1 and 2 correctly. So why is it fixed now? Because I is now inside its own scope within the IIFE. Whenever we pass I to myfunc, a separate copy of that I is created as a parameter inside myfunc. And that copy is what gets used inside the function. Everything is clear now. If we expand the dirs at the end, you will see the last one has I is equal to 2 in its closure. The second one has I is equal to 1 and the first one has I is equal to 0. Perfectly clear, isn't it? So, if everything is clear, I would say if you practice all these examples repeatedly, your understanding of closures will become much stronger. Of course, there are more complex examples of closures, but the basics we have covered today are the most important. Once you understand them step by step, you will be able to create many use cases yourself and debugging will no longer be difficult. Because now, with just a glance at console.dir or by playing with the code a bit, you can see how closures actually work. In summary, not understanding closures can make you get stuck in many parts of JavaScript, especially when working with asynchronous code. That's why I explained this topic in such detail today, went through so many examples so that everything becomes clear in one go. Now, if you are asked in a job interview, what is a closure? You can answer simply, a closure is a mechanism where a function remembers variables outside its own scope and can access them whenever needed. In other words, values that aren't inside the function itself, but the function takes a reference from its parent or outer scope. This is what we call a closure. So, closure is equal to function plus remembered values. This is why closures are so important in job interviews. They show how deeply a programmer understands JavaScript. If I want to recruit a JavaScript developer, a good JavaScript developer, then I will definitely put a closure-related question in the interview. A programmer who understands closures can clearly grasp JavaScript's internal behavior, memory handling, and asynchronous flow. JavaScript was originally created just for small interactive tasks in the browser. But now you can build large-scale applications, even backend systems with it. The reason behind this is powerful concepts in JavaScript like closures, prototypes, and more. Many people say, I know var, let, const, so tell me about closures. But as you have seen, var, let, and const aren't that simple either. this is where the understanding of closures begins. So, this was my detailed tutorial on closures for today. If watching it all at once feels overwhelming, you can break it into parts and watch it step by step. We have tried to explain the whole topic very simply, step by step. If there are any mistakes or if it took so long, we sincerely apologize. Still, I believe if you go through the entire tutorial, you won't have any confusion about closures. And from now on, you will never be intimidated by the word closure again. Thank you, everyone.